Today we'll see how to do analysis in frame structure. Right, this is a perfect example for the truss. Right, so this is a geometry. In this example you can see that a truss of span 5 meter is loaded as shown in figure. Find the reactions and forces in the member of the truss. So these things, first of all I have to model it and then apply the boundary condition, then do the analysis. Let's create the geometry. Span of 5 meter, 60. Right. What is the actual length? It is, you can see it is a AD is the length of 2.5 meter. That find out with this geometrical iteration with the help of AB is a 5 meter. So you can see this is a right angle triangle. This is a 90, 60 and 30. So with the help of this you can find out this side of this, and this is a 60 and 60. So the length of this is also 2.5 meter. That AC, AB, AD and DC. You can see AC, AD is 2.5 meter. Right. You can find out. Let's create geometry. Design modeler. Set your unit system, right? Unit 2 meter. XY. Let's start with the XY plane. Sketching. So use our grid system. 2D, and length of and width of each unit grid is 1 meter. So we can draw our geometry easily. Let's start it. First is 2.5 meter. You can draw 5 meter total. Let's 2.5, 1, 2 and 2.5. Apply the dimension.
5 करें split करें सही.
Yes, you can split it. Then there is angle of 60 and 30. 60, let's draw the line. Provide the dimension. Same, let's reverse it. 180 plus. Let's change. Remove this excess length, modify, trim. Right, this is one part. Then after you can see it is a 2.5 meter again. Then connect with this D point. And then after there is 60-degree length. Right, then after perpendicular 60, so actually it will become 30 over here. If you want to verify, you can give the dimension, but it shows the over constraint. Right, now you can see it is a 60 A7. So these are all our geometry. Let's remove the grid. Let's go to modeling. Now right now you can see it is a 0 part 0 body. We have to create, if you want to do the analysis, that must be parts inside. So for that, go to concept, line from sketch, right, select the sketch, then apply. Again you're supposed to do the generate. Now you can see one part, one body, but when you select this line body, it shows the requirement of cross sections. So let's assign the cross section. You can assign circular as well as circular tube, because in the example there is no any such requirement as given. So you can give the diameter of this, and let's make it default. Now assign that circular one, circular tube one, right? So let's see in view cross section solved. Now you can see it is form of 3D form. Our geometry is ready, right? Let's minimize. Then after, it is time for the meshing. We can do meshing inside, going inside. Let's make it update, so that meshing will be done by default setting. We will see in detail what type of meshings are there and how the meshing affects and what is the quality criteria for the meshing. Meshing is very important, that influence the end results. Based on the processing power, you are supposed to do the analysis for the meshing. Let's observe the boundary conditions. Here we have a geometry, right? Right now there is A and B are fixed. Here there is a force is 10 kN, 12 kN is provided. So generally, theoretically one end is fixed and one has a roller support. So right now we will apply the fixation condition first, then after loading conditions. Now you can see meshing has completed. Now next step is a setup. In setup, we will provide the boundary condition. So this is a procedure, like there is a 3-step: pre-processing, solution and post-processing. We are still in pre-processing stage. Now you can see, right, let's click on mesh. This is a by default mesh. Zoom to fit. Now next stage is a bounding condition. Let's apply fixation condition. Fix support, select the point load, then after roller support, select the point first, then go to support. Displacement based on axis, we are allow the movement in x direction, so x will be free, this will be constant. So now this is your fixation condition. Next stage is apply the force. There is 2 types of force. Let's see the value: 10 and 12 kN. So here it is a 10. Let's go to force and downward y direction. So there is 2 method: vector and component. Let's do the component method. Y direction 10 kN. Now you can see it is upward. Let's make it minus. Right. Take the next load. The value is 12 kN. What is a minus? Again. It is a vector, not vector, but component. Y direction minus 12. Now you can see the boundary condition: A, B, C, D. Right? Let's verify again with the question. Right? Now next stage is solution. Right click, solve. Now you can see solution of mathematical model. Now it has solved. What is required? First of all, let's see forces in the member of the truss and reactions. Let's find reaction. For the finding reaction, go to probe, force reaction. It asks for the fixed support or displacement. Let's place on fixed support, and then let's have another force reaction at the displacement. Evaluate. Now let's see the value. Reaction in y direction, the answer is 12,500 in y direction. And for the reaction 2, here about 10,000. Let's see theoretical value. RA and RB is the reaction. RA is 12 kN, RB is 10 kN. So we have verified with our answer. Right, it is nearly correct. Now next let's find the forces in each member. So for that, go to beam results, axial force, evaluate. Now you can see forces in each member. Let's animate. Now you can see the animation. Maximum force is 17,291 Newton. You can see minus and positive, compressive and tensile forces. Let's verify with our theoretical result. So for that, let's use the probe. Let's verify with the answer. Start from here. There is a F1, F2. F1 is a 13.85 kilonewton, F2 is 6.928. So 13.89, 6.89, 6.9 something. Then after this and this, let's see. At the B side, F4 and F3. F4 and F3. F3 is 20, F4 is 17.32. 20, right? Near about 20 and 17.29. So you can see these are in Newton and they are in kilonewton form. Then after over here, F2, F6, F5, F6 and F5. F6 and F5 near about same, but it is value is opposite, minus 10.392. And F4 is let's see, F5 10.39, 10.356, right? So these are in Newton. Let's this F4 17.291. F4, where is F4? F4 6 F4. F4, here you can see it is removed to F4 and F2. F6 is minus, assume F6 is wrong. Where is F4? Can you see F4? Where is F4? Let's direction F5, F6. Assume this was F2 and F4 are already known in magnitude. Okay, we already find out in here. F4 we already find out 17.32. Why I'm missing? Okay. Right, 17.29. So we have seen all the member that force induced in each member. We can also find out the stresses from the tools, from beam tool, evaluate. Now you can see the stresses on each beam. Maximum is 18 megapascal. That is in red form. Here it is the maximum stresses in this member. And blue is in compressive form. Here it is compressive form. Let's animate so you can have idea. So now you can see it is this is a compression in this member. Now here it is in tension. clearly you can see that. So this is a way to do the analysis. You can also find the deflection also, right? Let's find deflection in deformation, total deformation. Evaluate. Now you can see in mm 0.94468 mm, but it aesthetically look very high deformation due to the scaled one. Here you can see that auto scale is on. If you go to the true scale, like whatever the deformation is, now you can see it is actual deformation in form of visual form. So relatively you can scale it so you can better visualize the relative deformation of each link. Now you can see, right? So likewise one can solve many examples. Likewise, this is one of them. You can solve this example also. Right. Yes, you can change the cross section itself, right? Right now I have a pipe cross section, hollow pipe, but I want to change it to square. So let's add one more cross section, rectangular. You can provide the size, width and height, right? Then what you're supposed to do, change to circular to rectangular. Now let's see. Now you can see, right? It is a square one, but result, there is no effect on result. Now we require to update it. So let's update the project. This will apply to all the projects in this project schematic, but here only one project is there, so you can do it. Otherwise you have to do it sequentially. So likewise you can make iterative work like what if conditions by changing the cross section, and also you can add different links inside. Like if I add the link over here, what might be the deflection or stresses? So that what if condition you can very fast you can check, right? So in calculation or in practical it's take time, but in simulation it gives very fast result. Now you can see it has been solved. Let's see that. Let's see the reaction. You can see in reaction it will become exactly near. There is not much difference. Let's go to axial forces. Let's probe. Because in data there is no cross section has been mentioned, so you can apply anything. The reason is why we are not finding out the stresses, we are only find the forces. When the stresses are involved, at the time there is a cross section should be properly defined, because in finding the force you can see in this example, solved example, there is no stress values are there, no cross sections are there, that's why. So there is no effect on the values. So stress will be changed when we go to the stress point of view. It will be changed. Now you can see 173. It will be changed. Right? Likewise, you can make it different type of analysis in TRUSS base. So this is actually two-dimensional analysis, right, with the frame structure Likewise, you can do the analysis in this. Now you can solve different example from this book, right, and explore in more detailed way.